Okay, so we're on the fourth here. So yeah, it says design patterns. We're still looking at inheritance, but design patterns is very, very short. So most likely we will finish inheritance today and get to design patterns, and we'll be exactly on track. Nice headphone. What? I don't know. Tutorial 6 is of course coming up. It's due Saturday at midnight, and then, you know, well, whenever I wake up Sunday and mark them, basically. So yeah, so everything's kind of back to normal. Assignment 3 is due in, I guess, 1.5 weeks or so. So any questions on the schedule, or I also, you should have been able to see your midterms now. Is that correct? Can everybody see what they got and or the feedback? Perfect. All right. Actually, I can't with Brightspace. I can't tell. Okay, good. Any questions before we continue? All righty. So last class we were talking about, we started talking about this problem with the stack. Okay, so let me see here. So we wanted to implement a data structure. You don't see your grade. Yeah, okay. So I think I have to link your grade to the grade book. So I'll make a note of that. So midterm to grade book. Although I don't know what Brightspace, I'm not really setting up Brightspace correctly. What's going to happen is I'm going to download everything on an Excel sheet and just do it myself after, because, well, maybe, I don't know, unless Brightspace is completely very, very easy. But yeah, I'll get your midterm mark out to your grade section. Okay, so the idea is we wanted to make a stack. A stack is, of course, a data structure where you could think of it as a stack of plates or something. I guess maybe that's, anyway, we start with the first object. So this must be object 1. And then the next object goes, directly behind that. So O2 and then O3, and this is called a push operation. And then when we want to remove something from the stack, we call the pop function, and that removes it only from the in some sense, the top or the back, depending on how we are, depending on your particular model. So yeah, we only add and remove from the top of the stack or the back of the data structure. So there is a class in the standard template library called vector, and it is essentially like an array list, but it has all the methods that you would need to implement a stack. In particular, it has what's called pushback, which is analogous to this push operation. And it has a pop back, which is analogous to this pop operation. So this just means push to the back of the vector and pop from the back of the vector. So we wanted to make a stack class. So we're looking at, basically, we want to show how we would use private inheritance here. So, we looked at 3 separate ways that we could implement a vector in our stack class. The first was using public inheritance. So if I inherited everything publicly in my stack class, and then I might run out of space here. It's hard to draw over my keyboard. Pop. Sorry, I don't need. No, that's fine. And push and an empty. So I want to implement these 3 functions in my stack class, and so I'm going to inherit publicly from vector, and we'll see how that's done. Okay, so let me get. All right, so we want to make a class called stack1. So I've included the vector class right here. So now I'm free to use it. And it's a templated class, which we're going to get to later in the course. But for now, so I'm going to make a class called stack1. Yeah, and I'm going to make it a subclass of the vector class. And we're just going to, in our stack, we're only going to store integers. So when I say templated, it means I can make a vector that takes any type of object or type of data here. But we'll go with integers, and then all right, so we'll have some public functions here. So we'll have a push operation. I am going to, yeah, and we want to push some data item, and then we're going to use some, of course, bad software engineering here. So I'm going to put my implementation straight inside my class function. Sorry, my class template. No, it's not a template. It's a prototype. That's it. So in here, I can call, since I now have inherited all of the functions from vector, I can call the pushback and simply, sorry, I don't need int there. So I simply forward the call to my vector function that I've inherited. Right, so there, I've taken care of my push operation, my void pop. So I said that it's sort of standard to, when you remove something to keep a copy of it, right? But when it comes to pop, it's implemented a little bit differently on vector. So when we pop something off, we assume that you've already, if you wanted a piece of it, or if you wanted a reference to it, that you've already gotten it by doing a peek to the back or something like that. So we're not going to return any reference to the integer. Oh no, actually we do. Sorry. Yes, we do actually return a reference. So forget everything I just said. Okay. However, it's only going to be a copy of the thing, right? So we're not storing objects. So we'll say temp equals. Now we want to grab the thing that's at the back of the stack. Yeah. So the vector pop back does not return an object. So what we have to do is grab the thing that's at the back. So to do that, we want to grab the element that's at size -1, right? So if we know anything about data structures and indexes, the first index is 0. So if I have, for instance, 3 items in my, so if I have 3 items in my vector, then the last one is at location size -1, which would be index 2. All right, so yeah, we grab the last item in the vector and put it stored into our temp variable, and then we are going to pop the last thing off, and then we will return the item that we removed. And then finally, we want to ask if this stack is empty, and what we're going to do is simply forward this call to the vector class. However, the vector does have, we're overriding the vector function, the empty function, so we have to use the scope resolution operator to grab it, or to make sure that we call it correctly. Okay, so we're simply, in both these cases, we're simply forwarding the proper call to the call that actually does something in the vector class. Will we be covering virtual functions today? No, I think that'll be next week, early next week. Okay. So that's our stack class. I think that's all we needed. Yeah. So let's then, oh yeah, what did I do here? I need this. So I can make a new stack, and then I will push a bunch of items on it. So I'm just going to copy this code over because I typed too slow. Okay, so now I've taken, yeah, we don't need these. Not yet, we'll get to those. So I've taken my stack and then I've pushed 10 numbers on it. So I've just simply iterated from 0 to 9, and then I did a math operation where I added 1 and multiplied by 2, and then I pushed that number onto the stack. So let's see if that works. Okay, so we pushed 10 numbers onto the stack. That seems to work okay. We should actually, in order to test it properly, we should remove them as well. Number equals st1 dot pop equals, sorry. And then, okay, so we can pop everything off the stack and make sure that that works okay. All right, so it popped everything off in the reverse order that we put it on. So looks like our stack implementation works. Could we implement tutorial 6 like that? You're supposed to use the, I mean, now you got me worried. I mean, so for you can get away with it on the tutorial, right? You could actually implement tutorial 6 like that and get the marks, but you're gonna have to do it properly on the assignment. So the idea is, the tutorial is to, you know, sort of help you complete parts of the assignment. You would get away with it unless I saw it, and then I would probably give you 0. But yes, there are ways, of course, to cheat on the tutorials. The idea is you shouldn't want to cheat. You should want to use it to finish parts of your assignment. Anyway, good. Any questions on our first stack? So the one thing that is a problem is that I can do something like this now. I can say, I shouldn't be able to use random access on my stack. So random access means that I can grab something from the middle of my stack. So I can say st1 dot at, let's say location 3. And then, yeah, we will just, I don't need to see everything popping off the stack this time. So I can use random access, which if I have a stack, probably I want to limit people doing things that they're not supposed to be doing, right? So this is not typical stack behavior. So yeah, so there's some dangers to public inheritance because, you know, whatever I inherit publicly, other users of my class can see as well. All right, so then, yeah. So then, of course, another possible solution to this problem is if my stack uses a vector. So let's say I have stack 2. Sorry, just a little bit of housekeeping. So stack 2, and assume I have the same function calls here, and then I have a copy of a vector inside of my stack class. All right, and then I can still forward the calls to my stack, but if I make my vector private, then I'm hiding those things from other users. Is this why we would use private and protected inheritance? Yeah, exactly. So we're getting to, oh, did you mean for tutorial 6, did you mean privately inherit from the list class? Ooh, that's actually pretty, that's not how I intended for you to do it, but yeah, so you shouldn't do that. But that's an interesting, maybe for future assignments. Okay, so now I'm going to use I'm going to have a member variable of a vector, a private one. So it'll keep those things private, and then I can limit access to those things from other users. So I'm not inheriting anything. What I am going to have is a private vector. What did I call this? My stuff, sure. Okay, and it stores integers, and then, yeah, so now I no longer have this. If I want to push something, now I'm going to say my stuff dot pushback number. Okay, and then when I want to pop, I will say yeah, okay. And then, oh yeah, my stuff dot size. And my stuff dot pop back. Okay, so essentially I'm doing all of the same things and then empty return my stuff dot empty. So there's nothing really functionally different about what I'm doing here. It's a question of whether, you know, these function calls are part of my object or whether they are part of a, you know, an object within my object. So stack 2. Let's say we can push it on stack 2, and then we can pop it off stack 2. We'll just do this. Nope. I suppose I don't really need stack 1 here anymore. So we can see right away, of course, the problem that I had initially with stack 1 is no longer an issue because my stack 2 has no member at. I have no way to access the vector member variable. So this, where users have access to functions that I don't want them to have access to, that's no longer a problem. But let's make sure that it works before I pat myself on the back. So yeah, we push all the numbers from 2 to 20, and then we pop all the numbers from 20 down to 2. And random access is no longer an issue. Stack 2 does not use inheritance, just has one vector object. Yes, exactly. So stack 2, instead of inheriting from vector, I just keep a vector within my class, and then I forward those calls. Now, this is, I mean, arguably slightly less efficient, right? So sometimes we get really obsessed with efficiency in C++. I mean, and rightfully so, because C++ is designed to allow us to be efficient, right? So it's not uncommon to be that obsessed with efficiency. But so yeah, this actually has, you know, a little bit of extra overhead where I have to access this and then access this second function call. Does that mean the add is private to the vector class and its access is not allowed? Nope. So what it means is that my vector object is private, right? So if I wanted to So first of all, I have no add function, but let's say I wanted to say, grab my stuff dot at. So now it's going to complain that this is inaccessible. So there's no way to access the member functions of the vector class that I don't want to have accessed. Right. Any other questions? Okay. So, and actually this one also forwards function calls, right? So it's probably a little more efficient than stack2, but it's still not really efficient because, you know, I'm making 2 function calls every time here. All right, so let's look at, well, actually stack3 has the same problem, so never mind. All right, so let's try using private inheritance. Call that stack3. And now everything stays the same. I can still access within my class, I can access these public functions of the vector class, but now they are private to me. So it's as if I had, you know, defined it myself. I put pushback, but I had, you know, the private label here. Right, so you can think of it as it exists, but only I can see it. So then my stack3. Sure I'm not missing anything from that example. Yeah, everything stays the same. So we'll do stack3 dot push, and then we will do stack3 dot pop, and make sure everything works. All right, so we can push and we can pop off the stack. And the other nice thing about it is, if I try to access things that I'm not supposed to access, so the compiler is going to tell me, well, it's going to tell me something that I imagine, oh, inaccessible. There is inaccessible there. Some of these, man, some of these error messages in C++ or something else. But it does say inaccessible right here. All right. So the difference between stack1 and stack3 is just the word private instead of public. Yes, exactly. So this is, yeah. And in some sense, I guess arguably, you could argue that this is bad software, or sorry, not this one. This one is bad software engineering. There can be privates when you're, problems when you're trying to update the class and things like that. So it's, but it works, and it works pretty well. So I don't know. I guess it depends on what you want. If you want stack2 would I guess be the, I don't want to say recommended. Again, it depends on your goals, right? So private inheritance can be handy for things like this, where I want to forward calls to something else, but I want to hide all of the implementation of it. To be fair, if I wanted to make a really fast stack, I would just use arrays and I would just write my own. That's how you would do a really fast stack. But yeah, both work the same in the end. But the public inheritance, there's a danger that somebody could, for instance, off the top of my head, it's been a while since I used vector, but I'm guessing you could remove from the middle of the stack, let's say. And if you allow that sort of thing, that can really ruin, if you're assuming that you have a stack and it's going to work like a stack, then that can ruin, if somebody removes something from the middle, the implementation of whatever object is using that stack. So yeah, having stuff public that you don't want to have public can be a danger. So yeah. Any other questions? see, I didn't miss anything here. Hopping. Yeah. Okay, yeah. So perfect. All right. So private inheritance lets you cut through a little bit of, object-oriented programming red tape when you need it to. Yeah, I don't know. So this is an interesting little aside. I can't quite tie it into what I'm talking about. I don't know. When I wrote it, it seemed to make sense. But so when you use private inheritance, you pay in extra complexity, of course. But that's the story of C++ in general. So yeah. So this is another thing that is, C++ uses that a lot of other languages don't, is multiple inheritance. So this is when a class inherits from more than one base class. So it's not supported in many OO languages because it's messy. We're going to see some instances where things become ambiguous. But so when there is ambiguity, we can resolve it using the scope resolution operator. Yeah, so let's take a look at that example. Okay, so all right, so we're going to make a class. Again, we're using sort of bad packaging here, but that's all right for these examples. So we'll make a class animal. It's going to be very simple. It will have only some public members. And we will, no, we don't. No, it doesn't matter. Okay, so we will have, of course, a name member variable. Should clear that up. There we go, perfect. And I guess let's not get lazy about this. Let's do that properly. So yeah, so there's our animal class. It has a name, and that's it. So we can, yeah, should be able to declare an animal. Joe, whose name is Joe. Perfect. Okay, so now let's say, so a human is an animal, so let's make a class human. It inherits from animal publicly. My typing is so awful. Okay, and it's going to, yeah, we will have a private member variable. That is the number of feet, because that's, important information that we want. And we will have a public constructor that takes int feet and okay, so now we want to call the animal constructor. So we'll have, and we want to initialize this num feet. Okay, there we go. All right, so there's our human class. Simply have a constructor. It initializes, it calls the base class constructor, sends in the name variable, and it initializes its own private member variable. Okay, and let's have another subclass. A goat is an animal. Here, let's actually just do this. And goat has, sure, it has num hooves. Yeah, sure, that's fine. I'll leave this as num feet, just and all right, so we have two subclasses, and now we want to have, so if you ever heard of a fawn, it's this goat human hybrid. So we'll say class fawn is, I want to publicly inherit from goat and publicly inherit from human. So I'm going to use multiple inheritance here to get, I want to have a member variable that's the number of hooves and one that's the number of feet. All right, maybe number of arms or something, but for this example, this is what we'll use. So this will have one constructor that takes int num feet, int num hooves, and name. So again, we want to initialize, we want to call on our base class constructors. So we're going to call on the goat constructor. So we'll have goat takes, what is it, num hooves and the name. We also want to call on the human constructor. So we'll supply num feet there. And the human also takes a name. Okay. And what's it complaining about now? Oh, n. Perfect. Okay, so now we have 4 classes. All right, so let's take a look at what did we do here. I probably should have drawn this first, but so we have our animal base class, and we had a private name variable that's a string. And then we had 2 classes that inherited from it. So we have here we have a human, and the human has some private feet. I'm going to do a little bit incomplete here. And over here we had a goat. This human goat hybrid would have been a good lesson for Halloween, I think. But all right, we're not that far off. And this has a number of hooves. All right, so we have our class hierarchy here. We have an animal. We have 2 subclasses of that animal, a human and a goat. But then what we did is we used multiple inheritance, and we said, well, there is a human goat hybrid called the fawn. And so we want to inherit characteristics of both the human and the goat. Right, so here's my fawn. And I don't have to repeat these private member variables, the feet and the hooves. The fawn already gets them automatically. So this is my class hierarchy for this small example. Okay, so what does this mean on a practical level? First of all, is there any questions so far? Animal is a base class, human is a base class, goat is a base. So fawn is the derived class of all of them. But goat is a derived class of animal. So animal is the base class. but goat is a base class of fawn, and human is also a base class of fawn. Yeah. So we have this weird hierarchy. This is called a diamond hierarchy, by the way. Will the fawn get two names? Yeah, exactly. So these are the questions that come up. How does it deal with two constructors of human and goat? So we can say the animal is a base class of the fawn too. Yes. It's, in other languages, you use child and parent, and you would use something like grandparent, right? So this is, in C++, you say derived, or base, but yeah, those all still apply. So yeah, let's take a look at what happens now with the behavior of our. So we made an animal Joe, but let's say we wanted to make let's make sure everything works. Human with 2 feet. Let's call him Bob. And then we can say a goat. I don't know any good goat names. 4 legs. And then let's print out just to make sure everything is working up to this point. So we'll say Joe.name. Bob and Phil. All right, settle down. Okay, and let's make a fawn just to. So we have 2, 4. That might be backwards, and we'll call it Mr. Fawn. I don't know. Okay. And our name variables are public. So let's make sure everything works up to this point. So CD. Great. Yes. So the names of our animals, Joe, Bob, and Phil. So perfect. And then we have this Mr. Fawn. So let's see if we want to write out the name of Mr. Fawn. Well, geez. I'll actually give it a variable. Okay, so we can see it's complaining right away. So it says fawn name is ambiguous. So yeah. So what happened here? If we go back to our diagram, when we inherited, so human is a base class of animal, so it gets, even though we didn't draw it here, it has a name variable. And the goat also inherits from animal, so it has a name variable. And both of those we're assigned Mr. Fawn as the name. Right, so now we have 2 name variables in our base class fawn, which is, maybe not ideal, but this is what we're stuck with at this time. So yeah, as somebody mentioned, you can do, you have sort of the right idea. Fawn.goat.name, we could say, we use the scope resolution operator, get. Right, so if we want to access the goat name of our fawn, we can. And if we want to access the human name of our fawn, we can. Okay. Using the scope resolution operator, we can, yeah, both fawn names. We have Mr. Fawn and Mr. Fawn. So, so yeah, that's no problem, except for this idea that, yeah, that we have these multiple names, right? That's sort of silly. What we really want is only to have one name. So, I mean, for instance, we could do something like this. So fawn.goat, since these are public, dot equals Joe. All right, so I can change the goat name to Joe, and then when I print them out, what did I do? Sorry. Oh, sorry, it's multi-A or something. All right, so I've changed one of the fawn's names to Joe and the other to Mr. Fawn. So first of all, it's weird. It has two names. Second of all, it's wasteful, right? It's one animal. I only need one name. So how do we get that? How do we get that to be exactly one name? So what we do is we use the keyword virtual. So let's see here. Make sure I use it correctly. Yeah, so I want to inherit everything virtually. So I declare virtual public animal, and yeah, okay. So let's see what happens here. All right, so when I changed one name now, both of the names changed to Joe. It's funny, it's not complaining. This must be, yeah. So I think I'm using a different version of C++ than, because I'm using what is it? Because I think the compiler, because I have Visual Studio Code running in Windows, it's running a different compiler. Actually, they're both. Yeah. So it should be giving me an error here. So what virtual does is basically says that, yeah, if another class inherits from, say, the human class, it's going to be able to, in some sense, see the original animal base class. And then if I do the same thing with goat, then when I inherit from goat and human in my fawn class, it gets one copy of the animal base class instead of two copies, right? So in my original inheritance hierarchy, I was actually looking something like this. So even though this was my drawing, what I actually had was essentially two copies of animal. So one was here, and the other was there. Even though they're the same animal class, I had two copies of it in my hierarchy. Sorry, trying to get, All right, and then so that means that I have two separate name variables, and then I have to access each of them through their proper scope resolution operator. So when you add the keyword virtual to human, what it means is that it's sort of this, I mean, it seems like a weird place to put it, but it's like this pass-through command where I'm saying, hey, if ever you're in this diamond hierarchy, then, and somebody else inherits, well, in this case, the fawn inherits from both the human and the goat, and both human and goat inherit from animal, then you should only contain one copy of this base class, right? Instead of two. So that's sort of what's happening here. The other thing that it allows us to do is, or it should allow us to do.
Sorry, your mic is scratchy, so can you adjust your mic if you don't mind? There's a lot of things on the T.
Yeah. Sorry about that. Yeah. I start yanking on it after a while. Okay. So the other thing we can do is say, I can get rid of the scope resolution operator now and simply call fawn.name, since there's only one copy of this name and it's public. Still, it's worse. Yes, okay. Unplug it and plug it back in seems to be the solution. All right. Okay, and the other thing we can do is, so the other part of the lesson that doesn't seem to be an issue here, let me see here. So if we were using, so yeah, these were originally designed to be used with, of course, C++98, and I've sort of waived that requirement. However, if you were using C++98 in your fawn class, so I've called the goat constructor and the human constructor, but I would actually have to call the animal constructor directly. So I would have to pass in the name so that the compiler could resolve this, which actually makes me interested to see what would happen if I passed in. So here I'm passing in Mr. Fawn, but let's say for human I passed in Cindy. So now I've initialized goat with whatever name I passed in, and then I initialized human with whatever name I passed in, and I'm assuming, well, I don't know what's going to happen. Joe. Okay, so what happens if I do Cindy here, and then oh, sorry, did I change it to Joe? And that's what I did. Wow, this is really, all right. So yeah, I have to stop changing it to Joe here. That's what I have to do. So yeah, let's make this to N. I'm thinking Cindy might override. So let me just try this out and then I will explain what is happening. Both the fawn names are nothing. All right. So I do have to call the, okay, never mind. So in C++98, it'll actually give you an error. But what happens here is that I have to call this animal class directly and supply the animal constructor directly in order to supply the name. So supplying it here, and here you would think that it gets, I go into my human class, I look at the constructor, and I actually call the animal constructor in the human class, but it's no longer going to do that. So when I call if I have this diamond hierarchy and I want to initialize my base class, so my animal class here, and I want to initialize this name variable, then I have to call the constructor directly. I can't leave it to the human or the goat. All right, so now it gets Mr. Fawn as it should. And if I take this away, I guess I get nothing, even if I supply the same argument for both. Yeah, so I have to call the animal constructor directly. All right, so yeah, any questions on that? Why though? Okay, so is there any case where we shouldn't just use virtual inheritance always? I mean, there's off the top of my head, I can't think of one, but of course there's always an example. Maybe you want two separate base classes because they might store different, because name is, of course, I have one name, but there might be instances where I have some member variable that I want two copies of, because one copy applies to one copy applies to the other. So, I mean, that's a non-example, but maybe I can come up with one by next class. All right, so yeah, why though? Okay, so why is because in things like Java, we have, of course, interfaces, right? So I can, so each of my objects can take on multiple roles using an interface. So there's no multiple inheritance in Java, but I can have, say, I can have a car that is a vehicle, and then I can also make it an insurable object by adding a Java interface, right? Because I want that extra, I want to have in my insurance company, I want to have a bunch of insurable objects. Some of them are houses, some of them are cars, but I want them all to be insurable so I can sort of, do data, run some sort of operation on all of that data. However, in C++, there's no interfaces, right? And not in the Java sense. So we need multiple inheritance to do something like that, which is actually, often we have objects that take on multiple roles, right? So for like I just said, a house is also, it's a house, but it's also insurable. So in order to do that in C++, we need this multiple inheritance, right? So that's basically the reason. So we'll be able to do fawn.name instead of doing human fawn.human.name. Yes, once you add the virtual keyword here, then you can do fawn.name instead of calling human.name. Yes, which, I mean, that's what we have here. I'm guessing if you took off, I don't want to get too sidetracked on that. I love experimenting with C++ because there's always more to learn, but yeah. All right. Yeah, I was curious if I took away one of the virtuals, then you would probably get two independent base classes again. But yeah, that's something you guys can experiment with. All right. Any other questions? Both work. Are you asking if I could do human here? I believe I can. Human name, and I could probably do animal name. They should all print out the same things. Mr. Fawn, Mr. Fawn. So it's the same variable. And if I did this, it should also all be the same. So yeah, I changed the fawn.name to Joe, and it changed the human name and the animal name because they're all the same. All right. And so in your next assignment, yeah, if you change the human name, yeah, I'm pretty sure fawn.human, and then we can say goat. So both of those should still print Joe because they should still all be the same. Yeah, so both my fawn names are still Joe, even though I changed only the human name. Gross. All right. What was I gonna, oh yes. So assignment 4, you will be doing this diamond hierarchy thing. So as part of the assignment, then it'll also be it's a tutorial that I think I'm going to I might give you 2 weeks to do. Anyway, we have space for, I think I only have 9 tutorials. So one of them I'm going to extend it to 2 weeks because I think this diamond hierarchy thing, even though it seems simple here, once you get into more complex examples, it's all of a sudden not so simple, and it's easy. Even though it's a short amount of code, I feel like there's a lot of pitfalls. So yeah. All right. So if we have 2 of the same member variables, we can use the scope resolution operator. And in fact, it forces us to use it. Yeah, it's really, honestly, stuff like this, when somebody else demonstrates it, it's like, oh, that's easy. But then when you start to do it yourself, you're like, oh, wait, what was I supposed to do here? And how do I resolve this problem? So yeah, maybe you guys will have a simple time of it, and that'd be great. But if not, there is room in our schedule for an extra. There's a bye week for our tutorials. So yeah, if we have 2 of the same member variable, you got to use the scope resolution operator. But if we use the virtual keyword, then we must call the super class constructor. And in fact, any constructor that we want to, so any of the base class that we want to have initialized, we would have to call that constructor explicitly. Okay. So yes, types of multiple inheritance. If we have a distinct base class, right? So if we did not have a fawn at all, we just had a human and a goat inheriting from animal, then that's, oh, sorry, no, distinct base class. That's the opposite. If I had a fawn and I didn't have an animal, I could have plain old multiple inheritance, right? So I have a human and a goat. So I did not show you this example, but I can do this, and this is the, I guess, vanilla multiple inheritance in C++. We can have a multiple inclusion of a base class. So if I have an animal base class and I don't use the virtual keyword, then it's as if I have 2 copies of it. If you forgive my messy. So that's the multiple inclusion base class. And if we use a virtual base class, then the compiler recognizes that these are actually the same. So it only keeps, in some sense, 1 copy of it. And then, yeah, the problem, and if you're doing your assignment and you want some extra resources, just Google the diamond hierarchy problem, because it's a common problem, well documented, and the solution is well documented as well. All right, questions? How are we doing for time? 20 minutes. Okay, so that's inheritance in C++. So now we will go to design patterns and probably get through it. So design patterns, this is, in some sense, we're not going to get heavily into design patterns in this class. This is sort of introduction to 3004. But there's a few, I guess, smaller ones that you should know that we've already seen some of them, but yeah. So we'll do an overview. We'll look at the major categories of design patterns, and then we'll look at a few examples. So we'll look at the facade. These are the more popular ones. Facade, observer, and the factory design patterns, and then a thing that's called anti-patterns, which is actually when you just write bad code and don't use a pattern. Yeah, we're not going to look at too many of those. We'll just give a couple examples. So what is a design pattern? It's a way of organizing code to address a common problem. So there's a lot of problems in computer science that, of course, crop up again and again because, a lot of apps or applications are, dealing with similar problems, just with maybe different entity classes. So a design pattern is a way of organizing our code to address some common problem. So we can use organize via inheritance, delegation via composition, or composition alone, right? So that was our second stack class, where our stack was composed of a vector, and we used the vector class to forward our calls and solve our problems. We can specify operations to be implemented, or so there's a bunch of ways we can organize it. So the idea behind design patterns, sort of their genesis, was that back in the day there weren't as many programmers as there was today, but even the programmers that were around noticed that some problems happened over and over again, and then over time they would start using the same solution over and over again, and then they would go to their conferences and talk about it and realize, hey, we're both using the same solution even though we arrived at it independently. So then what happened is that this gang of four got together and wrote a book that is the sort of de facto authority of design patterns. So design patterns, elements of reusable, object-oriented software. All right, so they got together, they said, every time we solve a problem, we're using the same techniques. And they all sort of noticed that even they arrived independently, and so they got together and wrote a book. And so they put these design patterns into a few different categories. So there's a creational design pattern, structural, behavioral, and architectural. Architectural, some people say that these are not really design patterns. These are architecture styles, say styles. Really what it means is it's more an issue of scale, I think. So architecture is more big picture things, where I divide my classes into subsystems and then how those subsystems interact. So this is, whether we call it a design pattern or an architecture style is a matter of how big our program is, basically. And when we talk about design patterns, we talk about a client class, and this is the class that uses the classes in our design pattern. So creational specifies how we create objects. So a few to name are factory, abstract factory, or singleton. So a factory class is where I do not call the constructor of a class directly. I call an intermediate class called a factory, and I say, give me one of these types of classes. And so then the factory creates it based on whatever there's possibly, different things that it will take into account in order to decide what kind of base class object or what kind of object to give you, or what kind of implementation. And then it'll give you back a copy of an object. Abstract factory is, sort of similar. We're not going to get too much into that. A singleton means that I can only have one copy of the class, right? So trying to think of where that would be used. But so there are popular examples. It's slipping my mind. But if I have a singleton class, I make sure in the constructor, I check to make sure that no other copies of this class exist. And if no other copies of this class exist, then I create a new one and I give it to you. If I see that there is one other copy, then I just give you that copy, right? So I have a class and only one single copy of it exists. So those are creational design patterns. Structural are how objects relate to each other. So inheritance and composition. And this is so using inheritance and composition, but the facade, the bridge, the decorator, the proxy. So we'll see sort of what these mean. And then behavioral, describe how objects communicate. So which objects call which. So observer, strategy, visitor. We'll see a couple simple examples of that as well. And then, of course, the architecture style. So how they're grouped into subsystems. Yeah, so maybe I have multiple classes in what's called a subsystem. And then I have a bunch of classes in here that all work very tightly together. And then I offer services. There's a special UML for that. I think it's like this. So I offer services. So, that might be, this would be thought of as an API. So I can, for instance, Facebook has an API that you can, your program can talk to Facebook, and then you can build applications on top of their platform. And yeah, that would be how that's implemented would be an architectural style. Client server, peer-to-peer, model view controller. Yeah, so that's another popular one. Model view controller. I think we often implement it where the model, the view, and the controller are single classes, but that's, once you get into larger applications, then they become groups of classes that all work together. Okay. Structural design pattern. So a facade. So the name of the pattern is not the name of the class. One of those things again. Maybe there's a typo there. I'm not sure why I wrote that. But a facade design pattern provides a simplified interface to a complex class. So we saw that with our stack class, right? So the vector would be a complex class, and we offered a simplified interface to it with our stack. We just said push, pop, empty, and that's it. So that would be an example of a facade. So the facade class forwards these operations to complex classes who then handle it. So I might do things like I might have multiple function calls. I might check bounds, things like that. I might delegate these calls, right? Well, we've seen that quite often. So basically the facade hides away all the details, and I just say, I'll give you a couple of simple function calls. You decide which one you want to do, and I'll figure out all the messy details underneath. So Python, you can maybe think of it as a facade language. So Python is written in C, and if I do something like open file, well, there is a bunch of stuff that's going on at the operating system level that I don't see. All I know is that Python says, sure, here you go, here's your file. And then I say, well, can I read it? And that says, sure. Even though if I had to implement that in C, then I have to, initiate a byte stream and then read through and then find, the end of line and the end of file operators. So all of that is sort of whisked away by Python, and it offers a very simplified interface. All right, so the dotted line is a uses association. So my client class will make a call to my facade class, and the facade will make a bunch of calls to some other classes in order to make this complex thing happen. All right, so it's a general relationship, this use relationship. It could be composition, or it could be just I simply if I make a function call, I can pass in the object that I want to use to that without using composition. Right? And so, yeah, my, I guess go-to for this is if you're making a call to a file system, if I open a file, I read a file, I write a file, typically I could offer maybe some very simplified interfaces, right? So read file name, write file name. That's very simple, very straightforward. I get the information. I don't care how it's gotten, but um, underneath that or behind that function call, there's a bunch of C++ stream calls, and then there's some operating system calls, and then there's some device driver calls. So all of these things are happening. I don't know what they are, and I don't care. All I know is that if I want some data from a file, I just call read from that file name. Do we have to know this overhead? These are good exam questions, unfortunately. So we don't implement design patterns that much. We do sort of, you will be implementing design patterns, that's a thing, but I don't really point them out to you. I'm hoping you start to recognize them and start to recognize that the problems that they solve, right? So yeah, like I said, these are good exam questions. But facade, you see it kind of all the time. Because it doesn't even have to hide complex calls. It can be just forwarding a call, right? The stack is the good example where I do the pop operation. Well, there was a bunch of function calls that happened behind that pop operation. But in terms of, if you're using the stack, all you call is pop, and you know that it returns the element from the stack, and then that element is no longer on the stack. Yeah, the stack is a facade to the vector. Yes, or yeah, that's arguably, yeah. Other questions? So we're trying to, when you get to 3004, you're going to look at a whole bunch of design patterns, and some of them will be less useful than others. But here we're trying to stick to the ones that you might see most often, right? So facade, definitely you see all the time. Observer is another one. So if I want observer classes are informed of changes in the subject class, right? So this is commonly used in the model view controller architecture style. So in the observer design pattern, there's a subject class. It maintains a collection of observers. And anytime there's a relevant change made, it'll notify the proper observers, right? So whatever they're subscribed to. You will actually see that in assignment 4 as well. There's an observer design pattern, even though I don't think I really draw explicit attention to it. It's there. The observer class subscribes to the notifications and updates itself upon notifications, right? So if I want to be informed of certain changes, then I might make a function call, or I might pass off a pointer to that object to a different object. And then, yeah, there's usually some kind of callback function. So we're going to see how the observer pattern puts together a lot of sort of the higher level ideas that we're going to talk about, like when we get to polymorphism. So that is, right. So for instance, I guess, it's maybe not a good example. You'll see it in assignment 4, and we'll talk about it when we get to assignment 4. It's also known as publisher subscriber. So I guess maybe we'll talk about it in classic MVC, so model view controller. I got 5 minutes left, huh? So an observer pattern is if I have my model, and then, so this is not really UML, and then I have my view, So my model will be something, say it's a game, and this has my game data in it. And then the view takes the game data and says, displays it on the screen, right? So maybe there's a view, maybe there's a third person view and a first person view. They use the same data, but they display things a little bit differently. So now the observer pattern is that when the game data gets updated, then I tell the view, hey, something's changed, you got to update your view. So that's a good example of an observer pattern. And then maybe, this game model, if it's over the internet, I might have multiple views. So every time I update, I have a collection class of all of the different views of all of the different people that are playing the game, and I iterate over that collection and say, update all of these views. So then that's these would be the subscribers. And yeah, this would be the publisher. Okay, good. Questions? Okay, so yeah, this is sort of the higher level of observer. So when you see the italics, this is an abstract class. So often these are implemented using abstract interfaces, right? So I say, I want something that provides these functions. And then I don't really care how they are provided, or maybe how they are provided is really dependent on what my application does. So then I have a concrete subject that says, well, I know how to implement this stuff, so I'll do it for you. And then, yeah, so the observer, notify loops over all of the observers and calls their update function. So I have a bunch of different concrete observers, and I take the update function. When I call the update function, it calls the get state function from my concrete subject. So I get the state, and then I can update, possibly the view, as we just talked about before. All right, so yeah, this is sort of the UML of the observer design pattern. All right, questions? All right, so yeah, a more practical, specific example if we had an Xbox game, right? So the Xbox game is, it uses an interface to talk with the Xbox itself. Maybe the Xbox game is Fortnite, and the view is my, my character is living, so I update the view based on the living character, or the my character is dead, so I update the view based on, maybe I'm looking at another character. So view would be an observer, and controller would be the publisher. Yeah, the controller and I guess the model together would be the publisher, right? So yeah, these design patterns are sort of, divorced from even that amount of detail. So yeah, the controller and the model would work together to communicate with the view. The view would be the subscriber, and the information would come from the model itself. All right, factory. All right, we'll get to factory next week. So there's only about 3 more slides left, but yeah, it'll take 5 minutes next week, and we'll finish it up. All right, so that's it for today. I could stick around to answer any questions you have. Otherwise, I will see you guys next Tuesday.
Yeah, can I ask a question?
Yep.
Yeah, I had a question about the assignment. So